solving linear programming applications, both bounded and unbounded. Bounded's the more common case, but we can have that specialized unbounded case. All right, so steps to solve. First thing you should always make sure you do is clearly define what your variables are. What does X represent? What does Y represent? Usually, 99% of the time, X and Y are what you're looking for, what they're asking you to find. How much of this did we make? How much of this did we sell? How much of this? And so X and Y should usually represent whatever it is you're looking for. What do I need to do in order to optimize what it is I'm optimizing? Right? I think the objective function is the easier one, so that's usually where I start. What's your objective? Are you maximizing? Are you minimizing? What are you asked to maximize? What are you asked to minimize? And so I set that up first, and then I kind of set it to the side because I don't need it until I find my corner points. Right? So I find it, and then I kind of set it to the side. Right. Find your inequalities. So these should all be given to you in the problem. Right? They should have at least, at most, should be the common verbiage that we use. At least would be you want that amount or more. At most, meaning we want that amount or less. So less than that amount. All right? And so that's the hard part. This is the hard part, setting up the inequalities. Right. Graph the feasible region, locate and label your corner points. Right. So again, whether either case, you're finding your corner points. Right. If it's unbounded or bounded, the process is the same, and you only be given cases where it'll work out. But this is technically what you're doing. If it's bounded, you're guaranteed that you have both a max and a min. Right. Whatever it is you're looking for, you'll find. If it's unbounded, we can only look at one special type when all of my values are positive and I'm minimizing. Right? So if unbounded, we can only find minimizations. Bounded, I find both max and mins. Right? If the optimal solution exists, and ours always will, it will occur at the corner points. All right? So the corner points is always going to give us an optimal solution. Sometimes our optimum solution will occur too, and we did an example of that in the last set of notes, right? We had a case where she was making queen size beds or twins, and she had two options to optimize, all right? Depending on which option she decided to go, or depending on what the market was telling her to do, she had two choices. All right, again, you evaluate it by plugging them into your objective function and finding out whether you want max or mins, and so whatever value gives you out the most, and then you write your answer. All right, what's the maximum amount? What X value do you need to achieve it? What Y value do you need to achieve it? All right, and so that's the setup for what we're going to do. And so we're going to do, so that's just the FYI, and then I'm going to go and do the examples in the next. So I'm going to do one example in each video, because I think it's just easier. That way you could skip over this, because you know how to do it, and look at just the examples.